All right, we're gonna go through how to set up a ball bar test for a Hurco machine. In the future, when I get to a Fanuc machine, I'll create another video to go over how to set that up. Hoping by now you've downloaded the Renishaw ball bar software. The Renishaw ball bar software, it doesn't create an icon on your desktop when you first install it. You need to search for the Advanced app. The application comes with Quick Check, Advanced, and Operator. We're not going to use Quick Check or Operator. We're always going to use Advanced. Being that there is no icon that typically populates to your desktop, you're going to have to search for it down here in your search window the first time around. So search for it, open up Advanced. All right, this is the first page you're going to see whenever you open up Advanced. Set up and run a ball bar test. Okay, this screen right here is going to show you all of the machines that you've ball barred. Since John left, I've only ball barred one machine, so I've got one machine with results that I can go into and read. But we want to create a new machine. Anytime you guys do a new machine, we need to select this icon here. This icon is Add Machine. Right here, it's going to say Machine ID. I typically would add the customer name and model in Machine ID. So let's just pretend it's example VM10. In the description, put the model, manufacturer, Hurco, again, put the model. This information up here isn't as pertinent, but it is critical that you get the serial number. That way we have accurate information to give them in the future when we go to sell a ball screw. Controller, let's call this a Max 5, they're typically Max 5. Location. Location is going to be where you're putting the ball bar stylus on the table or on a fixture. Take note of where you're putting the stylus, if it's on top of a fixture, if it's on top of a vise. In the future, we need to recreate these same test circumstances. So here I'm just going to note center of the table. If there was a rotary, I would note center of the rotary or center of the vise or what have you. All right, so we've got an example machine loaded. Once you've selected that, this icon previously was add a machine. Now it's add test. We're going to add a test. First things first, we're going to create an XY test. This is going to test the X and Y axes. Make sure that your Z axis is selected, unless you're running a horizontal machine. We'll get to that later. That's a little bit more advanced. But you're selecting a Z VMC type machine right here. This shows horizontal. This is a lathe. We don't have the capability of doing that just yet. And this is a VTL style machine. Make sure you are using a VMC type test. We're setting up a test for XY. You don't need to change feed rate. Feed rate should be 1,000 millimeters per minute. Make sure that your test radius is accurate to the stylus length that you have selected. Let's just keep it at 150 millimeters. There's not really a reason to justify doing a larger test with the machines that we sell. Test position here again is information about where we conducted the test. Here it's going to be center of table. Program ID, give it something unique, because when this gets loaded into the machine, I want to be able to find the program if needed. This NC program ID is going to be very important when it comes to running on Fanuc type machines. This needs to be all numbers, no letters at all, no characters. This needs to be numbers. So for a Hurco machine, I do 4, 6, 2, 6, 8. Simple enough. This next arrow over here, As you can see here, there are different types of tests. When you do a test, it's important that the first test that you run and the next test that you run are the same. I myself like to do the 360, 180 degree overshoot. Don't worry about these here. All these options down here do is select whether the test is going to start on the left side of the table or the right side. Leave it as the default and just always keep it as the default. It'll be easier for you in the future. The only time you may need to change these is if you're trying to match test results for something that John has ran in the past and you see that your ball bar is traveling in the wrong direction relative to the readout on your laptop. But for the future, always select G03, G02. Once you've done that, this is generating a test. Let's save these test conditions. We're gonna save this as an XY 360 degree test, 150 millimeter stylus. Here you could also add the customer name, machine serial number, what have you, any notes pertinent to this test. You make that as long as you want, doesn't matter to me. Save that. We've just generated that test, and now we can go back to that and recreate that test in the future. All right, the next page. So you get to the next page, you can open this up, pre-test comments, anything you find weird about the machine, if the customer is complaining about backlash, this, that, the other, anything that you think that's going to be pertinent to this job. If you're running the machine without the way covers installed, that's a good thing to add. I know that Dustin and I just did a machine and we ball barred it without reinstalling the way covers. It would be a good thing to note in the pre-test comment section. Make sure in this operator field here that your name is written just for traceability. All right, so we've got that. We're gonna go to the next section. Okay. We need to, okay, I backed up. I went forward, didn't need to do that. All right, this, let me back up. Okay, after you've added any pre-test comments, it's called in here, doesn't matter. Anything you think that's pertinent to the accuracy of this machine, that'd be a good thing to note. This G02 icon down here is what you're going to select to generate the test program. Up here you'll see there's a field for controller. It's unspecified. We need to come into this and select Hurco, FANUC, EIA, mode inch. All right, we're gonna open that bad boy up. And you can read through a lot of this stuff. Pretty much everything I'm telling you is going to be here. I like to exclude warning texts. Once I've selected this type of controller, G02 is the type of test that I'm doing, so it's going to rotate, looks like clockwise. You can do a little simulation. That's simulating how it should move on the machine. Anyway, exclude the warning text. I don't care about the warning text. I want the program to be as simple as possible. Generate. Check right here. Read through all of that. Make sure that this all looks good. There are no characters in there that the machine is not going to be able to read. That program ID is 46268. That's what I typed in the program ID earlier in the setup. Again, if you had letters, the machine will not read the part program. All right, save this. You're going to want to save this onto the USB that you have ready to load onto the Hurco control. So save this whole thing. It's going to come out Hurco, FANUC, EIA mode, yada, yada, yada. This is the program. Go ahead and save. There's another video attached to this that you will see how to load. But anyway, we're pretending that we're saving it directly onto a USB that will be transferred to the machine. Okay. Once that has been saved onto your USB, you can exit out of that by hitting that arrow. You can go into this section. When you guys first set up your ball bar, you're probably not going to be connected to it. Up here, it's going to give you two options. You're going to want to make sure that you're selecting QC20, and there may be a discrepancy in the COM port that the machine is trying to access the Bluetooth dongle. Make sure that you have the Bluetooth dongle already plugged into your machine. The Bluetooth dongle is in the ball bar case. Make sure that it goes back in the ball bar case. We can't use that thing without the dongle attached. I'm going to show you where to find the setting to change your COM port if necessary. Take note, up here it will tell you what COM port it's trying to reach. Whenever I first set mine up, it was looking for COM port 1, but my laptop was set to use COM port 4. You're going to go into Device Manager to change that. You're going to go down to, let's see here, it's driver, general, driver, not this one, not this one. Here we go. Ports, COM, and LPT. Say, notice I've got this one set to COM 1. It was originally, I believe it was COM 4. Again, you have to match the COM port with whatever the Renishaw software is looking for. Now you can change that by going into port setting, advanced, right here, COM port number. I've set it to COM 1. Great. Once you change that, hit OK. OK. There may be an option to search for the ball bar if it doesn't connect immediately. Mind you, you have to have batteries in the ball bar. The lights on the ball bar have to be on or it's not going to connect. Once you get to this page, we will go to another video. It should be on the USB that I just gave you. So go down to USB 3, yep. So, does it say nothing is on that?
Yeah.
Okay, so no, that's good. This is a good exit. Go to aux menu, utility screen, user preferences, NC settings, and there should be universal. There's something that, it might be back, let's see here, user interface, show all file types. This right here needs to be a yes. Okay, so now you can exit out of that, exit, and then go back to your program manager, open, under there. Okay, excellent. So now there's, I labeled it arrow probe, so go ahead and load that one. All right, so it's open now.
Yeah.
All right, it's in your automatic. We're gonna select yes. Okay, great. So now, all right, so jog that thing in hand wheel, manually bring it over. You want to get centered up in X and Y. Now, the magnet's going to pull the ball up into the holder, so just slowly come down until it actually connects with the ball. Move it over a little bit left. There you go. Down slow. It's going to come up. You don't have to worry about it crashing. All right, stop. Once it's there, lock it. Don't move anything on the hand wheel. Go into your work offsets where your G54 is. So in here, you're gonna, all of these, you're gonna store the machine position and it's updating. We're not gonna change that because that's your rotary. So I don't want to change your rotary position.
X, Y, and Z are what's important though. Okay, so you can exit out of that. Exit. Now carefully jog Z up off of this. Go ahead, go up. Okay, go way up. Oh, yeah, real fast. There you go. All right, remove the ball. All right, so with the feeds low, let's just test that it's going to the correct location. Go into automatic. And you've got the correct part loaded. We're gonna do an XY test. Yeah, run program. And we're gonna watch and we're just gonna make sure that it moves to the correct position. It doesn't fault out for any over travel. So go ahead and hit start and just watch to make sure it doesn't smack into anything. So this is moving to the left side of the table. Verify that your test program in the Renishaw software is going to load on the left side. Go ahead.
All right, now I'm going to show you guys how to read the results and how to print out the results as a PDF. That way we can show the customers the befores and afters and justify all the time and hard work that we put into these machines. All right, open up again. You're going to go through advanced. We're going to review results. You have to have a machine already built. We've gone through in the last clip. This right here shows the different types of tests that I have performed. I did an XY and I did a YZ. Select which test you want to look at. Feel free to show the customer what you're doing on your laptop. It's kind of annoying when they're hiding over your shoulder, but I'll show you how to turn this into a PDF. Let's always output this in a 20 micron division. 20 microns is pretty easy to achieve, at least a perfect circle. If you're not getting a damn near perfect circle with a 20 micron division, you still have some work to do. To change that resolution, you got to be somewhere over this graph and you got to right click. Right here it's going to show you the division. Just for the sake of clarity, let's change it to 1 micron, apply. Now take a look at it. That looks terrible. Well, these machines are not 1 micron machines. Keep it at 20 microns. If the customer sees you with it at 1 micron and they see it making that funky shape, they're gonna, raise an alarm. Okay, so you've got your test information, your squareness, reversal spikes, yada, yada, yada. The thing listed at the top is your largest issue. The machine I was working on today was not square, but it's not bad enough for us to worry about re-leveling or any of that business. I was just doing a PM. I was giving them a baseline for the future. All right, so let's go over how to print it. There's a print icon up here. You can shrink to fit. I don't ever have to change that. Come over to your print icon. Your printer should be selected as Adobe PDF. All right, so we're going to print. It's going to open up this window. Doesn't matter to me where you guys store your information, as long as you can get back to it. Try to centralize it so it's all in the same location in case myself or one of the other guys call you asking for results. Dustin may ball bar a machine, and after he does the ball screws. Maybe I'm the guy that reball bars it and I need his tests from back, who knows when, a year ago. Doesn't matter. Put them in a central location where they're easy to get to. I've created a folder on my desktop, ball bar tests, segregated by the customer. I got a couple different customers. Today was AeroProbe. I saved them as the type of test that I did, XY or YZ. If it was before a ball screw change, make sure that you note in the file type, this is before ball screw change. And also note if it was after a ball screw change. It's important that we're getting as much information into these file names as possible. But after you've saved them, you can output this onto a USB. You can email it to the customer. Make sure that Alex gets a copy. Send them to everybody. Doesn't matter. The more places we send them, the better. It's going to generate a PDF, and voila. All right. So it gives you pertinent information. The ball bar was last calibrated, yada, 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 the machine type, the ball bar type. This is all the customer needs to see. They love handing these up to their management and telling them, hey, look at this. This justifies why we're scrapping parts. We need to spend some money. But that's it for the results.